All right, let's take a look at how to extract dialogue from our video clips. So again, we're going to use a model called Whisper, which is from OpenAI. If you're familiar with OpenAI and sort of the controversy of them right now is they don't really release a lot of open source models, but Whisper, they actually did open source. So it's fairly easy to use and it's fairly accessible, and there's some nice models to use. So let's get started. Okay, so for this, I do recommend that you use a GPU, although the lowest T4 is totally fine for this. I haven't had any problems running the T4 on this. So make sure you go to runtime, change runtime type, hi bug, and use the T4 with high RAM. Go ahead, save that, and then we'll run this, and this should output the T4 for us. There you go, so T4. And as always, let's connect to our Google Drive account. And we'll go ahead and refresh this, so we've got it. Next, we'll need to install Whisper, so we're going to run this command. If you're interested in all the help options within Whisper, or like all the options you can run, you can also run this next command. I'm going to skip it because everything is already set up for us. So first we're just going to look at how to run this on a single video clip. So as always, we sort of start with one clip and then build up from there. So the first thing we're going to need to do is actually import a model. I'm going to import the largest model, which will be a little bit slow, but it'll also be the most accurate. And that's sort of always the trade-off here, is that speed versus accuracy. And I would say, like, from my perspective, it's better to be slow because we're saving this stuff to JSON. It's like better to be slow and accurate and then do it only once. The faster models are good for stuff like mobile, or if you're doing like constant inference. But because we're running these once on our clips and saving the data, I think actually the largest model is actually good. It's also the one that is language flexible. We'll get to this a little bit later when we look at the model options that are available to us, but this one will auto detect what language it is, which is kind of nice because then we don't need to worry about like actually telling it what language it is. This does take a little bit of time to load. It is a 3 GB file, so it's not the smallest, not the largest. But while we do this, let's go and find a video clip. So we're going to go into our clips folder. And if you're following along with me, it should be an algo film clips. And then let's just grab a clip here. What clip should I grab from? Let's grab from X-Files. I feel like there's always dialogue in these X-Files pieces. One of the challenges here is I'm just going to grab a random piece and hope there's dialogue in it. If there isn't, then I'll need to go find a different one. Here we go. All right, let's grab a clip here. And we'll wait for this to finish downloading. And then we'll be able to see what's actually in this clip. Just about finished. Loading our model in. The other downside is that these large models are in fact large. They're the biggest file sizes, so this takes the longest time to load. But from here, once it's loaded, then it's ready to go. The smaller models load faster, but again, we are trading fast speed and accuracy for, those trade-offs are always the issue. All right, let's go ahead and run this next cell. This will just load our video and play it, and this will just help me make sure that I've got audio in my clip. Perfect. This is a great clip. It has audio for it, and we can actually just transcribe this. So the next cell will actually run the extraction process. The nice thing about this is we don't need to go and like convert this to an audio file. It does it all behind the scenes, which is amazing. Like, I've used other tools. We have to go and make the audio files, and then you've got to process them in other ways. It's really annoying. This will just take in the video and export out a audio file from it, I think, behind the scenes. That might also slow down the process a little bit, although I find this to be not the slowest in the world. And when this is finished, it's going to spit out like this thing that's called the result, which is a JSON file with a bunch of different data. So we can go ahead and look at this. So it says the text is the reason you're here, Agent Scully, is we want you to assist Mulder on these X files. So again, it doesn't do a great job of figuring out people's names. At least it knows Scully, but it does not know Mulder. It gives it as Mulder. I don't know why. So it goes. Beneath that are a bunch of segments. So this says from, within the start and end, which is a 3.84 second clip, which is about the length of the clip, it provides these texts. So it tends to provide, I think, these segments every 3 seconds, which means you can't get the actual word point, where the word is happening, but you do get a range. So if you have a minute-long clip, it'll give you every 3 seconds as a segment. We won't really use that for this, but if you wanted it, you could. It will also tell us that it figured out the language is English. So if you are going to run this on your own language models that are not English, you might want to run this first just to make sure it figures out the language. There's a detector inside of this model, but then there's also a way to actually assign it a language if you want to do that. So we'll look at that later. Other stuff in here, remember we talked about text embeddings. These are actually the embedding values, I think. I think that's what tokens are. Again, not my forte, but you'll see some other things. There's even a probability that there's no speech at all in it, which might actually come in handy in the future when we look at hallucinations. But this says there's a very, very low probability that there's no speech in it. That's probably because if you play this clip, there's no audio background, there's no background noise, it's just someone talking, which means you can clearly tell that it's someone talking. So this is now working the way we want it to. So now let's go ahead and actually run this on our JSON data, right? So we've probably seen this before. Also one thing I should mention is this results variable prints out all of this. If we want just the text, we can run result with just the text token. And that's going to return the reason you're here. This is just going to return just the text we want. And this is exactly what we want. So this is what we'll actually run when we do our for loop and loop through all the videos inside of our JSON file. Okay, so let's go ahead and run this. So I'm going to run this on, let's run this on just one of my clips here. I think I haven't run it on Blade Runner yet, so let's try this. So again, we're used to seeing this output, right? We set the JSON path. So our JSON path is, let's grab our JSON path here. So our JSON path is clips. Let's put this in here. So this will run over any clip it finds within this JSON file. So again, you do need to have already run the ffprobe at least to store it in your JSON. But this will go through it. I can filter this out. So let's just filter this out by Blade Runner. And again, this must match uppercase and lowercase with what is in our clips folder. So you'll see here my folder, my files are named Blade Runner. So that's going to look at that. Next, we've got our model size here. So as I mentioned, large is sort of the biggest model and the slowest, but also probably the most accurate. You'll see here there are tiny, base, small, and medium, and this sort of scales up from how fast they operate to how accurate they are. You'll also notice that all of them except for large also have a .en model as well as a non.en model, for lack of a better term. So .en means English, meaning this model is largely meant to be worked with English language stuff. If you have English language and it is and you don't want to use the large model, you want this to run fast or whatever, then definitely choose the .en model. That'll just be the most accurate and it will be meant to work with English only. If you have text that is in something else, and let's actually look to see what language it supports. So I've just gone to the OpenAI Whisper page, and you'll see here that these are all the languages it supports. So it supports Nepali, Swahili, a bunch of fairly, I don't want to call it uncommon, that seems rude, but languages that are not things that machine learning models are traditionally trained on. But you'll also see here that these scores, this is how good, for lack of a better term, it is at these models. So you'll see it is best at doing Spanish by a long margin, Italian, English, Portuguese, German. So again, the white Western languages that you would expect to see, although it is actually pretty good at Japanese, it looks like. So if you want to translate based on these, you should look at this. If you have films that are in these languages, it's not to say that it won't work, it just say that it might not be the most accurate. So that's sort of the downside of this here. So just be aware of that, but this does work fairly well. So there are a ton of languages supported. If you want to have it auto-detect the language and just sort of guess, make sure you set your model to the non.en version, so medium. By default, large is there is no large.english version. There's just large. So that's kind of why I also recommend just setting it to large. By default, this will always go and try to auto-detect the language. I don't have in here how to set the language manually. We can look at that if someone really wants to be. If you're finding that it's auto-detecting things in the wrong way, like, let me know and we can look at that. Okay, so let's go ahead and run this and just sort of see what happens as we run it. So first thing is we do have to load in our model. Again, remember these models are large, so in this particular case, I'm loading in the large model. It's going to be a little slow just to get started. I got an error message. What was our error message here? CUDA out of memory. Okay, this happens quite often when you try to load the model multiple times. The way to fix this is just to do restart runtime. Now, restart runtime is different from disconnect and delete runtime. Disconnect and delete like turns the machine off. This just restarts it and clears out the cache, which is what is going to help us here in order to remove the CUDA errors. CUDA is the GPU memory. So basically, when you try to load the model in twice, it tries to load it again, and it just runs out of memory space. Yeah, this is slow, so not ideal. Here we go. Now we are reading in our JSON data. So again, remember it's reading all of our JSON file. There's a lot of data in our JSON file because we've done the OpenPose stuff. It's quite a cumbersome file, but it is kind of slow. So now we're actually running through and processing our data. You'll see I've already run this a couple times on previously existing content just using this filter word. So what I kind of like about this is like this filter word allows me to not process all my data at once. I'm starting to work on some data sets that have like hundreds of films in them, which are very, very large. And this process is not the fastest, so I really don't want it running over my entire data set because that's just going to take forever. So in this case, I can kind of say like only run it on these particular set of clips. So in this case, only run it on this set of clips called Blade Runner. And I really need to work on fixing this code a little bit so we're not hitting these saving files all the time, but we're getting closer here. Again, because this file is so large, it also takes time to save out each file as well. I would generally recommend that unless you definitely need the OpenPose data for whatever you're doing, probably skip saving that to this particular JSON file. I'll probably at the end of class also generate like just some best practices. And one of those best practices I would say is like generally save OpenPose for last because it saves out so much data and it really bloats the files, and maybe even save that to a separate file. So then you can save like a JSON equivalent file that only has pose structure in it. So you're not waiting on all of this, and you're not like me having to vamp while we wait for things to load so I can actually see what the output of this is. Okay, I might just pause the video and we'll come back when this is finished or ready to output. Okay, so it's just finished. It only took maybe 10 minutes, but it was annoying because I like to keep these tutorials short. I've now updated the text and the code in here so that hopefully this runs a little bit faster for everyone next time. But regardless, like we can see the outputs here. So if I look at the outputs for my Blade Runner trailer, you'll see looks pretty good. Unfortunately, I don't actually see the issue. Well, maybe this one is one. So as I mentioned, there's some weird like hallucinations that happen in these models. I kind of think that anywhere you see the word "you" on its own is a hallucination. Might mean there's actually no audio in that clip. I need to dig in and investigate a little bit more. I was seeing this other thing where it was like, thanks for watching, which was popping up in a bunch of other places, but I definitely don't think it was in the original audio. So again, not a perfect model. It will not always give you the best results, but I do actually look here and I think they're pretty decent. I see even, maybe it's even outputting Chinese, or is that Japanese, Chinese? Sorry, I'm very bad at that. So it might even be doing multilingual within the model itself, which is pretty interesting. So some decent results worth using in future processes. So this has now been saved to our JSON file. One last thing I want to show you, when we start to talk about using our dialogue as fragments and be able to repiece stuff together, one thing we can do is we can actually pull from our dialogue elements and then ask GPT or do it ourselves to resort things or play with those pieces. So this cell here will actually pull all of our dialogue fragments from our JSON file. And then when we run this cell, which is just as dialogue, it will output what's called a Python list. So you can tell it's a list because, oops, all the way at the top here, we see a square bracket, and all the way at the bottom, there's also a square bracket. So this is a list within our file of all of the particular text elements. So this we can use in our next tutorial to actually resequence things. But you'll see here there's a bunch of U's on their own lines. Let's see if I can also find the thanks for watching stuff. Yeah, thanks for watching. Thanks. Like that clearly isn't in my video. Anyway, you can see all these different pieces. Now we can take this and copy and paste this into ChatGPT and say like, hey, do stuff with this, or like recreate a new dialogue using these assets. So this is kind of a fun thing. We'll look at this more in the next tutorial, but I just wanted to mention that you can do this as a way to sort of get access to your data and begin to play with it. We could also say, I think we do slicing in this. So we could say, give me the first 100. Yeah, that works. Cool. So I'll explain slicing maybe in a different video. We could say, give me the next 100. And just get those pieces. So again, if you don't want to work with thousands upon thousands of slices of language, you could use this to just get out those pieces. So really interesting use here. Let's jump to the next video and start to look at how to use this in sentence similarity and begin to rebuild our video clips.